Hello and welcome to our BERT sentiment analysis on Vertex AI using TFX series. This is episode 1 out of 4, Motivations and Tools. My name is Tomasz Maćkowiak and I am an ML engineer at DLabs. There are going to be 4 episodes in this series. The first one is going to talk about the motivations and tools. Why do we want to approach this subject? Why do we care about MLOps? We're going to set for ourselves some goals that we want to solve using machine learning, and we're going to talk about the tools that we're going to select to solve our problem. In the next episodes, we're going to talk about how to create a machine learning model to solve the problem. Then we're going to talk about creation of a pipeline that will be able to train such a model, and finally about how to run such a pipeline both locally and in the cloud. If you prefer to read instead of listen or watch, you can head straight to our article. This is a full version of this material, unabridged. You can find there also links to all the open source code of everything related to this material. That means the modeling code, the pipeline code, and our open source TFX helper library. So let's talk about motivation. Why even approach the subject of the presentation? If you were to ask your data scientists how to create a valuable ML model, they will probably start thinking about what kind of architecture of a model to use. They might start thinking about some fancy feature engineering. They might start talking about hyperparameter tuning. They might want to implement something they've seen in a recent research papers. But to a business owner, this all is just cost, risk, delay, and no tangible business value, because in real life, it's production or nothing. The best model that you have in your notebook is not gonna bring any business value unless it's deployed to production. And we as data scientists are not that great at delivering our solutions to production. Why is that? In my personal opinion, there are 2 factors to this. The first factor is us. We as data scientists are not always coders at heart. We use tools like Jupyter notebooks that require a bit of manual labor and are not directly deployable. And the second factor is that the field is rather difficult. The models that we produce are computationally heavy. You cannot just drop a machine learning model into a Flask application and hope for the best. Also, our models come with huge dependencies. If you include any kind of machine learning framework into your application, you are going from megabytes of dependencies to gigabytes of dependencies straight away. And we also have a big problem with pre-processing. What I mean by that is that our models, they are usually comprised of 2 things: pre-processing, all the feature engineering, transformations, and so on, and the proper model that is doing the reasoning. And very often we have a problem where to put the pre-processing. Is it part of the application? Is it part of the model? If it's supposed to be part of the model, how do we incorporate it together? Because it's usually done using different tools than the model itself. For example, the pre-processing can be done using scikit-learn libraries, and the model is in TensorFlow or in PyTorch. So how do we go about integrating this together into some kind of coherent model? That's why we all need MLOps. We believe that the whole field needs standardization, and we started to look for libraries that could help us achieve this kind of standardization. And we turned our gaze towards TensorFlow Extended as a likely candidate for a good solution. But we found ourselves in a bit of a niche. It turned out that there are not that many online materials on the subject. They are usually in forms of notebooks or single-filed code bases. They present rather simple pipelines, and they don't always show the best coding practices. So we had this idea that we would try to do a deep dive into TFX. We will try to solve a practical problem using the framework. We'll try to adhere to better engineering standards, and we're going to publish the results. And with it, you can find the full article and the open source code under this link. It's a very comprehensive article, and we publish also all the code related to modeling to the pipeline and our TFX helper library. You can read it after watching this presentation. So we wanted to solve a practical problem, so let's try to set ourselves for solving some problem. We decided to go with a supervised learning model for text sentiment analysis problem. Why text sentiment analysis? Because it is a very intuitive problem. You get a text and you need to decide whether it's positively emotionally charged or negatively emotionally charged. It's a binary classification problem, and we wanted to solve it using as many ready-made components as possible to accelerate the development. We found ourselves a dataset of 50,000 IMDb movie reviews on Kaggle. The dataset contained text of a review and a sentiment, both as text, where the sentiment could be just positive or negative. Very simple dataset. For creating a model to solve the text sentiment analysis problem, we wanted to have an automated end-to-end machine learning pipeline. The pipeline is supposed to import the CSV, it's supposed to do some basic exploratory data analysis, it's supposed to train and tune a high-quality natural language processing model, then it should evaluate this model against a set of metric thresholds and also compare it to the previous best model trained. And we wanted the pipeline to finally deploy the best model to the cloud as an endpoint for serving live predictions. So we hope that at the end of this series of videos, you're going to learn two things. First one will be how to build a sentiment analysis model in TensorFlow, and the second one would be how to build and run a TFX pipeline in the cloud. Let's talk now about the tools that we're going to use to solve the problem. The first tool is going to be BERT. It's a natural language processing model developed by the researchers at Google. It was trained on a huge text corpus on Wikipedia text and on book corpus. When it was published, it was state-of-the-art, and it supports many downstream tasks through a combination of transfer learning and fine-tuning, and it's very widely used in the industry. It became kind of a go-to model for anything NLP. Why do we want to use BERT? Well, first of all, it's a very high-quality model. You can achieve very good results with it. Second of all, it provides us by default with a summary vector for each text we give it as an input. This is going to come in handy later. Fine-tuning of BERT is optional. You can fine-tune BERT, meaning you can modify it to fit your particular problem, but you can also use it verbatim without fine-tuning, just taking the base BERT model and building stuff on top of it without changing the base of your model. That is going to help us because it's going to be faster and it's going to use less computational resources. Also, BERT comes with very easy TensorFlow integration by using the TensorFlow Hub library. The main thing we're going to use though is TFX, which stands for TensorFlow Extended. It's part of the TensorFlow ecosystem, and it's a framework for creating end-to-end machine learning pipelines. It supports many built-in components that you connect together kind of like Lego bricks, where output from one component becomes input to another component, and the components themselves, they implement quite complex logic. Why do we want to use TFX? Well, first of all, Google uses this framework internally, so it's bound to be useful to them, and we want to learn from the best. It supports very complex functionalities out of the box through a set of connected libraries like TensorFlow Data Validation, TensorFlow Transform, and TensorFlow Model Analysis. It has a support for large data sets. It doesn't work in the way that your scikit-learn usually does, where you read your whole dataset into memory and you fit some transforms on it. It rather works in kind of a batched approach. It uses actually Apache Beam underneath the hood. It's largely code-free, meaning that for most of the components you just provide configuration, but you don't need to actually provide any implementation of stuff that needs to happen. You are relying on the implementation included with TFX, and it enables you to have pre-processing as part of the model. This is a big selling point. As I was saying, one of the problems with deploying machine learning models to production is that we don't know where to put the pre-processing, how to incorporate it into a single coherent model artifact. TFX solves this problem. The pre-processing that you're going to do using TFX can become an integral part of your model artifact, which then you can just drop to deployment as just an artifact without providing any code, just with a data artifact, which can be loaded into a serving platform such as TensorFlow serving, and do the whole process of doing the pre-processing and the model execution together. It simplifies the deployment process immensely. In the course of our work, we were finding that there could be some things to improve with TFX, and we created this library called TFX Helper, which we published as open source. You can find it under this link. It provides some things on top of TFX. First thing it changes compared to the standard TFX is that we provide a unified interface to creating pipeline components. We found this pattern in lots of the materials on the web, where if the pipeline was supposed to run both in the cloud and locally, it was looking like this, that there was always an if. If you are supposed to run in the cloud, then use a cloud specific component, otherwise use a non-cloud specific component. We didn't like it very much. It made the code of the pipeline definition very complex, hard to read, and unnecessarily verbose. So we provide kind of an abstraction layer on top of that, which enables you to write your pipeline definition without any if statements and with less parameters. We also simplified component configuration, especially for those cloud-enabled components. If you wanted to configure what kind of machines your training should run on, what kind of GPUs should be included. It was kind of cumbersome to figure out the exact job definitions that you need to provide to configuration. So we did this research. We exposed just simple parameters that you can declare, and we're going to take care of making this complex configuration for you. And last thing, we allow resource customization per component. TFX by default runs all the components on kind of a standard machine on Vertex AI, but the platform underneath, the runtime, enables you to customize the resources for each of those components. We kind of patch it into, and now you can say that a specific component in your pipeline requires more memory, and you define how much memory it needs, and the runtime is going to provide you with a bigger machine for this particular component, allowing it to run smoothly. We want to use Vertex AI. It's part of Google Cloud Platform. It's a set of machine learning services, a very wide set of machine learning services, out of which the one that we are most interested in is serverless ML pipelines. Why do we want to use Vertex AI? Because of those serverless pipelines. We love serverless pipelines because if you use them, you don't need to manage Kubernetes cluster. That means that you don't have to care about providing the resources, having them running 24/7. You provide just your workload to the runtime, and the runtime takes care of allocating resources for as long as your pipeline is running. Once the pipeline finishes running, the resources are deallocated and you stop paying for them. This enables you to be quite cost efficient. So that's the end of the first episode. We talked about the motivations and tools. In the next episode, we're gonna be talking about the model on conceptual level, how to create it. Then we're gonna implement all the steps in creating a model. The next episode, we're gonna talk about the pipeline definition. And in the last episode, we're gonna be talking about running this pipeline in the cloud. And once again, you can find the full article and open source code used in this whole series of videos under the link below. Thank you.